practicing dimensional analysis using molar masses and atomic masses. A 7.36 sample of copper is contaminated with an additional 0.51 grams of zinc. Suppose an atomic mass measurement was performed on this sample. What would be the measured atomic mass? So there's a sample, 7.36 grams of copper, and it's contaminated with 0.51 grams of zinc. A measurement was done to figure out the atomic mass of the entire sample, including this contamination. You want to figure out what that is. So you want measured atomic mass. We know we have grams. We want to figure out what's in the total. It's always safe to go to the periodic table and write down the molar masses known. We know copper has a molar mass of 63.55 grams per mole, and zinc has 65.38 grams per mole. So, since I know individually these masses, I can figure out how many moles I have in both. Because if you think of atomic mass, molar mass, you want total. So want total molar mass, which means you need to know total grams over total mole. So you need to figure out how many total moles you have of copper and of zinc together. So 7.36 grams of copper divided by the molar mass will give you 0.1158 mole copper and 0.51 grams zinc divided by the molar mass will give you 0.0078 moles of zinc. So then total moles in sample is zinc plus copper, which will be those two added together, and that's 0.1236 mole. Just to be a little bit more clear, it was 0.0078 plus 0.1158. All right, so we have the total mole, then total mass is equal to, since it's this amount of copper that's contaminated with that much zinc, the total is the two added together. (7.36 plus 0.51, which gives you 7.87 grams. And then atomic mass, the measured atomic mass, will be grams per mole. You take your 7.87 grams over 0.1236 moles, and you find that that comes out to be 63.67 grams per mole. So if you look back at what you're given up to 3 and 2 significant figures, so your answer should be in 2. However, if you place this answer in 2 sig figs, you would get 64 grams per mole, which is correct with the rules of significant figures that we've learned, but we look at this as a mass, and our masses from the periodic table are always up to 2 precision numbers, 2 digits after the decimal point. So it would be 63.67 to be really precise of what the atomic measured mass was of this compound.